Dear friends, welcome back. In this video, I'm going to show you how to connect this 1-inch color OLED display to a Raspberry Pi Pico board. I'll also show you how to use it with CircuitPython, and I'll share with you 3 useful projects to help you get started and save you a lot of time. Let's start. This color OLED display is one of my favorite displays of all time. I have used it in some Arduino projects in the past and I really like it. The advantages of this display are the following. It is a color display that uses the OLED technology, which means it has a very high contrast ratio, a wide viewing angle, and a very low power consumption. The disadvantages of this display is that it is small in size. It is just 1 inch in diagonal, and it is a bit more expensive than other displays. It costs around $10. The display has a resolution of 96 by 64 pixels. It supports 16-bit color and it uses the SPI interface to communicate with a microcontroller. The connection to the Raspberry Pi Pico board is very easy. All we have to do is to connect power and 5 more wires. The first pin of the display is the ground pin, so we connect it to a ground pin of the Raspberry Pi Pico board. The second pin of the display is VCC, so we connect it to the 3.3 volt output of the board, which is right here. The next pin of the board is named SEL, so we connect it to pin GP18. The fourth pin is named SDA and we connect it to pin GP19. The next pin is the reset pin and we connect it to pin GP16. The next pin is named DC and we connect it to pin GP20. The last pin is named CS and we connect it to pin GP17. Easy, wasn't it? Our connections are ready. Let's power up the board to see what happens. As you can see, the display works and it displays a demo script, a simple Pong game where both paddles are controlled by the Raspberry Pi Pico. Cool! As you can see, the Raspberry Pi Pico board is fast enough to let us develop games on it with a color display. Let's now see the software we need to drive this display. In order to use the display with CircuitPython, we need to download the Adafruit SSD1331 library to drive the display and some other helper libraries. If you want to recreate all the projects I'm going to show you, you need to install the following libraries: the Adafruit SSD1331, the Adafruit Display Text, the Adafruit Display Shapes, and the Adafruit Image Load libraries. To install the libraries, we have to download the CircuitPython libraries bundle from this link and unzip it on our computer. Since I developed the project using CircuitPython 8, we need to download the bundle for CircuitPython 8. Now, all we have to do is to locate the needed libraries and copy and paste them inside the lib folder in the CircuitPy drive, just like this. Your CircuitPy drive should now look like this. We have a code.py file with the script to run on the board and a lib folder with all the libraries required. You can find links to all the files needed in the video description. The first example program is a simple project which just displays a green frame on a purple background and a yellow hello world text. I am using Thonny as my editor. As you can see, the code also supports the LilyGo ESP32S2 board or any other board that can run CircuitPython if you define the correct SPI pins here. The second example is a simple version of a Pong game where the CPU is controlling both paddles. The project consists of 3 files and you have to copy all of them in the CircuitPy drive and run the code.py script. The aim of the project was to test if the Raspberry Pi Pico is fast enough to allow us to build some games with it, with a color display. As you can see, it is very fast, the animation is very smooth and it looks even better in person. There is no flickering at all in reality. Very cool. Also, I wanted to test the power consumption of this setup. With the script running, I measured that this setup, a Raspberry Pi Pico and a color OLED display need around 32 mA of current to operate. So even a small battery with a capacity of 350 mAh is enough to power this project for more than 10 hours. Great, we can build a complete Pong game with these parts, so stay tuned for this. The last project is a simple project that displays an animated icon. As you can see, the animation is very smooth and it looks so cool. Now we can add animated icons to our projects to make them look even better. And the cool part is that it is extremely easy to do in CircuitPython. Check this out. All we need to do is to place a sprite-sheet image in the CircuitPy drive and using the excellent Adafruit image load library, load and display the animation. Amazing stuff! Now I can hear you ask, but where do I find these sprite-sheet images for the animations? Don't worry, I have you covered. I developed a simple Python script that takes any animated GIF and turns it into a sprite sheet ready to be used with CircuitPython. Check out the detailed video about the procedure here. Also, I have prepared a detailed tutorial on how I developed this Python script on my second channel. Check it out now if you want to know how it works or if you want to modify it to work with another display. This video will also teach you the basics of image manipulation with Python. Thanks for watching, I'll see you next time.